Hi guys, in this video we are going to look at second order differential equation of the form a d square y dx square plus b dy over dx plus cy equals to 0. I know that this is an homogeneous equation. Now we are going to look at example. This example, it says determine the general solution of 2d square y all over the x square plus 5 dy over the x minus 3y equals to 0. Then find also the particular solution that when x equals to 0, y equals to 4, and dy over the x is equals to 9. As simple as ABC, it is not difficult. Follow me on my YouTube page, subscribe, and share it. Is that clear? God will bless you. Okay, let's look at this idiot. Amen. Okay, we'll write down the differential equation. 2d square y all over the x square plus 5 dy all over the x minus 3y equals to 0. Amen. Okay. Whenever you are asked to find the general solution of this homogeneous equation, second order differential linear homogeneous equation, what you need to do is, you can use the operator to solve it. Then at the end of the day, you substitute a for n. That's but here I'm going to use number approach. Okay. First, what you need to do, you now let y, since the dependent variable here is y, that clear? So let y equals to a exponential mx, that clear? So that we are going to differentiate this function with respect to x twice. So if we differentiate this function, it means our y prime will give us an exponential mx. Since it is a second order differential equation, we are still going to differentiate this function again to give us y prime prime will give us am squared exponential mx. Is that clear? So what you need to do here is for you to substitute in this and this into this differential equation by writing, note that this is the same thing as this. So 2am squared exponential mx, then plus 5, our y prime here is this. This is an exponential mx, amen. And what we have here, minus 3y. Our y is a exponential mx times a exponential mx, which is equals to what? 0, amen. Okay? Life of mathematics is always beautiful with Mr. OSI. It's not difficult. Okay? If you can follow OSI on YouTube, mathematics won't be a problem. Okay, look at the left hand side. What are you seeing? Are you seeing what I am seeing? Look at the left hand side. We discovered that something is common here. Two of us. What is common? What is common here is a exponential mx. Two of us. So you factor it out. That is our a exponential mx, all in bracket 2m squared, amen, then plus 5m minus 3, all in bracket, equals to 0. Then if a exponential mx not equals to 0, it implies that our 2m squared plus 5m minus 3 is equals to 0. So we call this is called auxiliary equation. This is our auxiliary equation. Auxiliary equation. Amen. This is our auxiliary equation. Now it is in the form of what? A quadratic equation. True or false? So you don't need the prophet to tell you, you know how to solve quadratic equation by using either the formula method or factorization method. Okay? Let's use the formula method where our n is equal to minus b plus or minus square root of b squared minus 4ac all over 2a. Then you know that your a, where a is equals to 2, amen, b is equals to 5, and c is equals to minus 3. So if you agree with me, our n is equals to minus 5 plus or minus square root of all in bracket square minus 4 times, sorry, this is 4ac. Is that clear? Okay? Okay. 4 times c times minus 3. Oh, sorry, a is 2 times minus 3 all over 2 times 2. True or false? Okay? So our n is equals to minus 5 plus or minus square root of 5 times 5 will give us 25. Then minus 4 times 2 minus 8. Then minus 8 times minus 3 will give us minus 24, isn't it? Here will give us a minus 24 all over 4. Amen? Okay? So if you agree with me, please listen very attentively. Our n is equals to minus 5 plus or minus square root of 25 minus 24 is 1 all over 4, where you know that square root of 1 is 1. So here is minus 5 plus or minus 1 all over 4. True or false? Amen? Oh, sorry. Here is a plus. Sorry. Please, sorry, bear with me. Yes, because minus 4 times minus 3, minus 4 times 2 will give us minus 8. Minus 8 times minus 3 will give us plus 24. Please, sorry, take note. Please, I'm sorry, very sorry. Please bear with me. That is mathematics for you. Okay? So m is equals to minus 5 plus or minus 25 plus 24 will give us 49 all over 4. Yes, now square root of 49 will give us minus 5 plus or minus 49 will give us 7 all over 4. But you know that plus or minus is the same thing as plus, minus. Either you use plus first to obtain the value, then you use minus to obtain the value. Is that clear? So, are you following? So if you agree with me, let's first use plus. Minus 5 plus 7 all over 4. This is equals to minus 5 plus 7 will give us 2 all over 4. This is equals to what? 1 all over 2. It implies that our m is equals to 1 all over 2. Then our m2 is equals to minus 5. We now go by this minus 7 all over 4. This is equals to, it will give us minus what? 12 all over 4, isn't it? So this to this will give us minus 3, right? So our m2 is equals to minus 3. Amen? Okay. So now our general solution will now be, we know that the root of the auxiliary equation, which is this equation, are equal and what? Different, real and different root. Is that clear? Real and different. That is, m1 is equals to 1 all over 2 and m2 is equals to minus 3. So the general solution will now be y equals to a exponential m1x plus b exponential m2x. So if you agree with me, what is your that is general solution? What is your m1? Therefore, our y is equals to a. Our m1 is what? 1 all over 2x plus our m2 is minus 3x. This is the general solution. Is that clear? Now, the question says, find also the particular solution that when x equals to 0 and y equals to 4 and y over x is equals to 9. How can we obtain our particular solution? Is we are going to use this general solution to obtain our particular solution by using the boundary condition. X equals to 0, y equals to 0. It implies that we are going to have at the end of the day two simultaneous equations. Is that clear? Okay. Let's go. Let's say to obtain a particular solution. To obtain a particular solution, note that the boundary condition. Note that our x is equal to 0.